Good morning, student. This is Mohnish your SSC teacher. So, as we have already started climate chapter and we were doing Indian monsoon. So, in Indian monsoon, we have studied how Indian monsoon arrive in India. So, few of the important structures we need to study today. For example, we are going to learn and understand what is jet stream, right? And what are western cyclonic disturbances. We are going to do it. And as we have already, like, we have already started mechanism of monsoon. So we have done differential heating and cooling of land and water, ITC jet shifting of ITC jet, third high pressure area east of Madagascar. Then D is Tibetan plateau gets intensely heated. That is fourth. Fourth one is what? Tibetan plateau Tibetan plateau gets intensely heated. Right? So we are going to understand it. What is the role of Tibetan plateau? So Tibetan plateau during summer, which results in strong vertical air currents and the formation of low pressure all over the plateau at about 9 kilometers above sea level. So let us understand. Let us understand this one. Okay. What happens in condition over the Indian subcontinent in the month of January? So in January, like this is equator. Okay, this one is equator, which is at 0 degrees Celsius. And in January, what is there? It is winters. So what happens in winters? Sun is at actual place, that is at 0 degree only. Its sunlight directly falls on equator, right? So what happens? These are winds which are crossing equator, and over equator we do have what? A narrow belt. That belt name is ITC JAD, Intertropical Convergence Zone, or doldrums. We have already done it. And those who don't understand what is ITC JAD and doldrums, they can view my last videos. Right? So ITC JAD or doldrums, is it clear? When the winds are moving towards equator. They see this is Africa. Here we have India, right? Australia. So what happens? Winds are moving, and when it cross the equator, cross the ITCZ, winds started shifting towards the right. Winds will turn towards their right. right? But it happens in when? It happens only in summers because over here low pressure is there, right? When what happens in winters? Let us understand this. See, when in winters sun is at actual place and sun comes at actual place, and over here in summers there was a low pressure, right? Now in winters when sun comes down, sun will heat this Madagascar land. In southern hemisphere, other than Africa and Australia, we don't have any land near to India, right? We don't have any land over here except Madagascar. So Madagascar started heating, started heating, and when it started hitting, low pressure creates over here. So when low pressure creates over here, it will attract all other winds to fulfill this empty air, right? So it will attract winds from northern India. The winds will blow from northeast. The winds which are coming from northeast direction, then these winds will be known as northeasterly. So they will come downwards, right? And what happens? It will also attract it will also attract winds from northern India. So over here we have a Tibetan plateau, right? When sun shift downwards, over here sun will not heat in large amount, like sun rays will not fall on Tibetan plateau as it falls in summer. So what is going to happen? High pressure will create over here. When high pressure will create over here, winds will blow, and on upper air there will be low pressure. When low pressure is there, winds which are coming from European countries, it will flow over the Tibetan plateau, right? So these winds which are flowing above Tibetan plateau, these winds are known as jet streams. So let us look over here. What is the definition of jet stream? See, they are a narrow belt of high altitude about 12,000 meters. Westerly winds in the troposphere. Their speed varies from 110 km per hour in summer and to about 184 km in winters. So what happens in winters? As all winds settle on Tibetan plateau. Over here, low pressure generates, and when low pressure generates, it will attract all other winds towards Tibetan plateau at higher, right, at a higher level, right? So winds will be around 184 kilometer per hour on Tibetan plateau. So these winds are what? These are jet streams. And how it is created? It is created because, let us understand once more this thing. Just a second. Okay. So here we have Tibetan plateau. As we all know, sun moves shiftwards in winters. What happened when sun moves shift downwards in winters? Tibetan plateau will not heat because rays are not falling directly. When rays are not falling directly, what is going to happen? High pressure will generate because high pressure, high pressure will generate on Tibetan plateau? Because there is no heating. When there is no heating, molecules of air will come and settle on Tibetan plateau. So high pressure will over here, and on upper on above Tibetan plateau, this area will attract all other winds towards it, and these winds flow around 184 kilometer per hour. That means these are what? These are known as these winds are known as jet streams, and it also flow in summers. That is 110 kilometer. Let us understand in what happens in summers. See, sun moves upwards in summer. In winter, sun is over here, and in summer, sun moves 5 degree upwards. When sun moves 5 degree upwards, sun rays will fall on Tibetan plateau. That is plateau, which is above the sea level, right? When Tibetan plateau rays, direct rays will fall over Tibetan plateau. So what is going to happen? These waves, these whatever air is over here, it will started hitting and it will move upwards. So when it will move upwards, what is going to happen? It will over the Tibetan plateau, there will be high. It will generate high pressure, and over here it will generate low pressure. So it will attract less winds on Tibetan plateau in comparison to winters. In summers, it will attract less wind, and its speed will be 110 kilometer per hour. In winters, its speed goes beyond 184 kilometer per hour. So this is a basic difference. So these winds are what? These winds are ITC jet, right? This is all about ITC jet. So right. So we have understood what is ITC jet. It is clear to all of you, right? After this, we have fifth point. As we have already done, the Tibetan plateau gets intensely heated during summer, which results in stronger vertical currents and the formation of low pressure over plateau at about 9 kilometers above sea level. So what is going to happen in summer? Formation of low pressure will be there on the plateau, right? And it will attract less winds. So its speed will be 110 kilometers. And next is the movement of westerly jet stream to the north of Himalayas and the presence of tropical easterly jet stream over Indian Peninsula. The westerly jet stream and tropical easterly jet stream. Next is westerly jet, jet stream. And what? Westerly jet stream and tropical easterly jet stream. See, in month of June, what happens? Low pressure generate over here, right? And it will attract winds which are coming from southern hemisphere, right? These winds are what? West, or you can say westerly wind, right? And what is happening in winters? These winds are coming back and crossing equator, right? These are northeasterly winds. So this is all about what we have done and understood: jet streams. So once you read all the textbook till where we have studied, right? So Indian monsoon. Let us read this Indian monsoon one. The climate of India is strongly influenced by monsoon wind. The sailors who came to India in historic times were one of the first to have noticed the phenomena of the monsoon. They benefited from this reversal of the wind system as they came by sailing ships at the mercy of winds. So I have already explained you, when the Europeans wanted to come India, they just come in India at the mercy of the winds, without any fuel. They use the winds support, and they used to come in India. So we have understood these 5 points. And what else? We have southern oscillation. Yes, this El Nino we need to understand. This is a name given by periodic development of a warm ocean current along the coast of Peru as a temporary replacement of the cold Peruvian current. El Nino is a Spanish word, right, meaning the child, and refers to the baby Christ. As this current starts flowing during Christmas, the presence of El Nino leads to an increase in surface area temperatures and weakening of the trade winds in the region. Let me explain you what is El Nino, right? I'm starting this video and try to understand this. What is El Nino?
In a few years, the El Nino phenomenon kicks into life in the Pacific Ocean around the equator. It can affect weather around the world, changing the odds of floods, drought, heat waves, and cold seasons for different regions, even raising global temperatures. But what is El Nino, and how does it happen? Firstly, we need to know what's normally happening in the tropical Pacific. This vast stretch of ocean sees consistent winds, called trade winds, that blow from east to west. These winds push warm water near the surface in their direction of travel, so the warm water piles up on the western side of the ocean around Asia and Australasia. On the other side of the ocean, around South and Central America, as the warmer water gets pushed away from the coast, it's replaced by cold water which is pulled up from deeper down in the ocean, a process called upwelling. This creates a temperature difference across the tropical Pacific, with warmer water piled up in the west and cooler water in the east. Warmer water adds extra heat to the air, which causes the air to rise with more vigour, and it's this rising air that creates an area of more unsettled weather, with more cloud and rainfall. That rising air in the west sets up atmospheric circulation across this part of the world, with warm, moist air rising on one side of the ocean and cooler, drier air descending on the other. This circulation reinforces the easterly winds, so this part of the world sits in a self-perpetuating state until El Niño begins. If conditions are right, tropical Pacific weather systems, or slow changes in the ocean around the equator, can set off a chain of events which weaken or even reverse the usual trade winds. With weakened trade winds, there's less push of warm surface water to the western side of the ocean and less upwelling of cold water on the eastern side. This allows the usually colder parts of the ocean to warm, cancelling out the normal temperature difference. Because the area of warmest water moves, so does the associated wet and unsettled weather. This changes rainfall patterns over the equatorial Pacific, as well as the large-scale wind patterns. It's this change in winds which has a knock-on effect, changing temperature and rainfall in locations around the world. The main impacts are around the tropics, where you see an increase in the risk of floods in Peru and droughts in Indonesia, India and parts of Brazil. But virtually wherever you are in the world, El Niño has the potential to affect you directly via the weather or indirectly via socio-economic impacts. There's another impact from El Niño which happens because of all the extra heat at the surface of the tropical Pacific. This releases vast amounts of energy into the atmosphere, which can temporarily push up global temperatures. This is why El Niño years often feature among the warmest on record. Each El Niño event is different, so the global impacts can change. You can find out more about the differing impacts of El Niño on our website. El Niño peaks around Christmas time and lasts for several months. It can die back to neutral conditions, but sometimes reverses into La Niña. This is the flip side of the oscillation, which sees a strengthening of the normal trade winds. This pushes the warmest water to the far western part of the tropical Pacific and increases the upwelling of cold water in the east. This cooler water extends out from the coast of the Americas towards the central part of the ocean. La Niña also impacts global weather and tends to have opposite effects to El Niño. You can also see more about La Niña and its impacts on our website.
So we have seen the video about El Nino. El Nino is what? Reversal of winds. The winds which are flowing in a particular direction. So winds just get reversed and it flows in reverse direction. And due to that, where there is rainfall is there, it will cause heavy rainfall. Right? Where there is a less rainfall or no rainfall, it will cause drought over there. So this is about El Nino. So we have understood ITC jet stream, El Nino, right? Read this textbook. If anyone is having any issue, you can ask me in next class, right? Then we have onset of monsoon and withdrawal. Okay, let us do onset of monsoon and withdrawal. So monsoon, unlike the trades, are not steady winds, but are pulsating in nature, affected by different atmospheric conditions and countered by it. On its way over the warm tropical seas, the duration of the monsoon is between 100 to 120 days from June to mid-September. So when it started raining from June to September. Around the time of its arrival, the normal rainfall increases suddenly and continues constant for several days. So when the rainfall is occurring continuously for several days, that thing will known as burst, burst of the monsoon, and can be distinguished from the pre-monsoon showers. The monsoon arrives at southern tip of the Indian Peninsula, generally by the first week of June. When monsoon arrives in India, it arrives in June month. So subsequently, it proceeds into two Arabian Sea branch and Bay of Bengal. How? Let us understood. So when these winds, which are coming, which has crossed equator, or you can say ITCZ, winds will flow into this direction. Okay, and these winds will divide itself into two parts. Half of the winds will flow in Arabian Sea, and this part of the winds that will flow in Bay of Bengal, right? So when these winds are flowing, and why these winds are flowing? Because sun has moved 5 degrees upwards, and when sun has moved 5 degrees upwards, due to sun's shifting of 5 degrees northwards, northern India, including Tibetan Plateau, it started heating, and that is due to the northern plains. It started heating. A low pressure arises. When low pressure is created, it will attract all other winds towards it, right? So let's see more. So the Arabian Sea branch reaches Mumbai about 10 days later on approximately 10th of June. This is fairly a rapid advance. The Bay of Bengal branch also advances rapidly and arrives in Assam in the first week of June. Lofty mountains causes monsoon winds to deflect towards the west. So what happens? It started raining in Goa, Mumbai, Western Ghats, and on the sides of Arabian Sea and Bay of Bengal, branches of the monsoon merge over the northwestern part of Ganga Plain. Delhi generally receives the monsoon showers from Bay of Bengal branch by the end of June. By the first week of July, Uttar Pradesh, Punjab, Haryana, Rajasthan experience the monsoon. By mid-July, monsoon reaches Himachal Pradesh and the rest of the country. Okay, and in September, withdrawal of the retreat of the monsoon. Retreat of the monsoon is what? When monsoon is going back, is a more gradual process. The withdrawal of the monsoon begins in the northern states of India by early September, because sun again started shifting downwards at its normal position, right? It withdraws completely from the northern half of the peninsula. The withdrawal from the southern half of the peninsula is fairly rapid. By early December, the monsoon has withdrawn from the rest of the country. And the island received the first very monsoon showers progressively from the south to north. From last week of April to the first week of May, the withdrawal takes place progressively from north to south from the first week of December. So what happens? Let us understand fast, because now we have to end the class. Time is about to over. Okay, so when these winds are coming towards over here, so over we have Western Ghats, Eastern Ghats, this northeast. So since starting of 1st June, monsoon arrives over here. Rainfall started falling over here and started falling over here. So maximum rainfall will be where? Maximum rainfall will be in northern east, right? Maximum rainfall will be in this area, right? This will, and while moving towards west, it will started reducing the rainfall. Now it will have a less rainfall, then less rainfall. Okay, it will also have less rainfall. So over here, Western Ghats and this part and northeast states will have a heavy rainfall. And while moving towards west side, rainfall will be lesser. And if you come to Rajasthan, Saurashtra, Gujarat, or you can say about in Rajasthan, rainfall will be lowest, right? And when sun again started shifting downwards after September, then low pressure which was generated in summers, it break down because sun direct rays will not fall over here. And in southern hemisphere on Madagascar, what's going to happen? Sun direct rays will fall. And when sun direct rays will fall on Madagascar, there will be a low pressure, and over here will be high pressure. On northern plains, it will be high pressure, and the winds will go back in this direction. And winds will started going back in this direction. When it's going in this direction, right? So rainfall, it will have a little bit rainfall over here. This is what going back of monsoon is, retreating of monsoon. So student, we have a one question I would like to give you all. Question is what? Question number 1. How monsoon arrives in India? Explain in detail. And also explain retreating monsoon, right? And one more thing, you need to explain what? These remaining 2 points as well in your answer, which was I have already given mechanism of monsoon. You need to explain these 2 points more. Okay, and this is you all need to do in detail. That is 5 marks of this question. So thank you so much. Do it and send it to me. Thank you so much. Have a great day. Take care. Bye bye.